Good day everyone. Let's try to answer a suggested question from Master Marcus Tiger. And let's start. Here's the question. The small and medium circles are tangent to each other, and both of them are internally tangent to the big circle. The gray area is 2 pi square units. And the question is, what is the length of segment AB? Now, if you want to try this problem, just pause this video, and if you're ready, here's the solution. And I hope you pause this video. Now, let's see if your answer is correct. First thing to do is to locate the center of this medium circle and the center of this small circle. Let's draw a diagonal directly to the point of tangency, like this. Now take note that both diagonal of these two circles is perpendicular to the tangent segment AB. Therefore, the red diagonal and the blue diagonal creates a straight line. Now at this point, let the radius of this small circle be equal to r sub 1, and the radius of this medium circle be equal to r sub 2. Now the question is, what is the radius of this big circle? Now we know it's diagonal. The length of the diagonal is equal to 2 times r sub 2 plus 2 times r sub 1. Next, we know that the radius is half of the diameter. It follows that the radius of this big circle is equal to r sub 2 plus r sub 1. Now at this point, we will use some given on this question. And one of the given is the gray region must be equal to 2 pi square units. And the question is, how do we find this gray region? To get the gray region, what we're going to do is to find first the area of the big square minus the area of this medium square and the area of this small circle. Now since we have the length of its radius, so we can set up an equation that is equal to 2 pi. So we have the area of the big circle is equal to pi times r squared, or simply r sub 2 plus r sub 1, minus the area of this medium circle, and the area of this medium circle is equal to pi multiplied by r sub 2 raised to 2, minus the area of this small circle, which is equal to pi multiplied by r sub 1 raised to 2. And again, it is equal to 2 pi. Now at this point, we can now divide all terms by pi, and will give us r sub 2 plus r sub 1 squared minus r sub 2 squared minus r sub 1 squared equals 2. Simplify the first term and we get r sub 2 squared plus 2 times r sub 2 times r sub 1 plus r sub 1 squared. Now as you can see, we can cancel out r sub 2 squared and r sub 1 squared. Therefore, we have 2 times r sub 2 times r sub 1 equals 2. Divide both sides by 2 and we get r sub 2 times r sub 1 is equal to 1. Now keep in mind that the product of r sub 2 and r sub 1 is equal to 1. Next, don't forget our goal. Again, our goal is to find the length of segment AB. Now let segment AB be equal to 2x. It follows that this segment be equal to x and the other segment is equal to x. Now to solve for the value of x, we will use chord-chord power theorem. Chord-chord power theorem states that if two chords intersect in the interior of a circle, then the product of the measures of the segment of one chord is equal to the product of the measures of the segments of the other chord. Now in this diagram, we can say that A times B equals C times D. Going back to our diagram, we know that this red line is equal to 2 times r sub 2, and this blue line equals 2 times r sub 1. Now, using this chord power theorem, we have 2 times r sub 2 times 2 times r sub 1 equals x times x. Now, simplify and we get 4 times r sub 2 times r sub 1 equals x squared. Now, recall that we have a value for r sub 2 times r sub 1, and it is equal to 1. Therefore, we have 4 times 1 equals x squared. Now, take the square root both sides and we get the value of x is equal to 2. Now, since we have the value of x and the length of segment AB is equal to 2x, therefore, the length of segment AB is equal to 2 times 2, or simply 4 units. And we're done.